place our hearts for Semio Biotruck.
Greetings from Semio Biotech. We will take you to Biotech campus, located at Jalan Raya Tajun, Bogor, West Java, Indonesia.
As the community learning park, Semio Biotech is equipped with 14 research laboratories as well as greenhouses and research fields.
Welcome to Semio Biotech. We know that over 50 years, Semio Biotech has contributed to address tropical beverages issues in the Southeast Asia and beyond. Through research, capacity building development, and publication, we envision to be a leading center in promoting and enhancing the real values to tropical biology in Southeast Asia.
Hydroponic and aquaponic units.
Culture Laboratory. Animal marketing culture. Biotechnology Laboratory.
Remote Sensing and Ecology Laboratory.
Soil and Plant Testing Laboratory.
Entomology Laboratory. Aquatic Laboratory. Biotechnology Laboratory. Air and Water Testing Laboratory. Herbarium. Biosystem and Landscape Management Laboratory. Natural Product Laboratory.
Greeting from Siamio Biotrop Indonesia. Wish you all are in good health and happiness. Please allow me to proudly present the Siamio Biotrop achievement as an expression of our commitment to betterment of the society in the Southeast Asia region.
All the activities and achievements are mostly impossible without strong commitment from our staff and available supporting facilities and resources. During this fiscal year, our center installed required management and infrastructure to deliver program and activities in accordance with the new normal era. The success of the organization is supported and complete by excellent resources, including its human resources, facilities, and management system. For the fiscal year, our center received the supporting funds of about $1.5 million following the fiduciary standard of the government budget scheme. Our center also received a special education development fund of about $71,000 to support our regional activities and donation from various institutions and generating income from dormitory rentals and interest from bank savings.
Our Earth is faced with environmental losses and damages, plant pests and diseases, breaking of the food chains, floods, and long droughts. Within our journey of more than 50 years, Siamio Biotrop is committed to consistently and continuously maintain its contribution and supports in sustainably managing and conserving the biodiversity and environment in Southeast Asia. We have great dreams, strong hopes, knowledge and capabilities to fulfill our vision. We have prominent extraordinary expertise to be the legacy for the future generation.
Regional Center for Tropical Biology is one of 26 regional centers under the Southeast Asian Ministers of Education Organization, SEMIO, located in Bogor, West Java, Indonesia. SEMIO Biotrop, that was established on the 6th of February 1968, aims to promote regional cooperation to address tropical biology issues in the Southeast Asia. Governing Board is the highest body in the center's organizational structure. The rector of IPB University has a privilege to serve as SEMIO Biotrop Governing Board member from Indonesia. Tropical biology issues develop dynamically through three main mandates, namely research, trainings, and information dissemination. SEMIO Biotrop conducts its programs and activities to contribute significantly in addressing those issues. Program on School Fruit Garden for Education, Production, Genetic Conservation and Entrepreneurship in Agriculture Vocational Senior High Schools in Indonesia, SmartBee, and Program of SEMIO Biotrop to support the vocational schools revitalization. SEMIO Biotrop is supported by prominent experts in implementing its programs and activities. Products as the outputs of SEMIO Biotrop's program implementation. SEMIO Biotrops its international networks, linkages, and various beneficiaries. SEMIO Biotrops is equipped with quality facilities in conducting its activities. We place our hearts for SEMIO Biotrop.
Greetings from SEMIO Biotech. We will take you to Biotech campus, located at Jalan Raya Tajun, Bogor, West Java, Indonesia.
As the community learning park, SEMIO Biotech is equipped with 14 research laboratories as well as greenhouses and research fields.
Welcome to Siamio Biotrop. We know that over 50 years, Siamio Biotrop has contributed to address tropical beverages issues in the Southeast Asia and beyond through research, capacity building development, and publication. We envision to be a leading center in promoting and enhancing the real values to tropical biology in Southeast Asia.
Hydroponic and aquaponic units.
Tissue culture laboratory. Animal muscle culture. Biotechnology laboratory.
Remote sensing and ecology laboratory.
Soil and plant testing laboratory.
Entomology laboratory. Aquatic laboratory. Breeding Laboratory. Herbarium. Biosystem and Landscape Management Laboratory.
Morning, ladies and gentlemen. May we have your attention? We are going to proceed the program shortly. Please kindly turn on your camera and mute your audio to avoid feedback during the event. Thank you. Okay. Honorable, the Director of Simeo Biotrope, the distinguished resource person, participants, manager, supervisor, affiliate scientists, and Simeo Biotrop staff. Assalamualaikum warahmatullahi wabarakatuh. Good morning. Selamat pagi. Om Swastiastu, Namo Buddhaya, and salam kebajikan. A very warm greetings to each and every one of you. On behalf of the organizing committee, allow us to welcome all of you to the talk of Affiliate Scientists Series 6 with the topic on biotechnology innovations for food security and environmental sustainability in the changing times. Ladies and gentlemen, as our first program, may we invite you to sing the Indonesian national anthem, Indonesia Raya. Please rise. Ladies and gentlemen, kindly remain standing. May we present Simeo color. Ladies and gentlemen, kindly be seated. May we present Simeo song.
It's time to open our eyes to a bright and promising future. We'll rise to the call of the times and create a stronger tomorrow. Let's start to make a difference, teaching everyone to learn through science, health, and technology. We will share our expertise by promoting knowledge and policies. We can build a better world. Let us take a step for our visions of hope, bringing future plans for the people to grow in a life filled with happiness and dreams. Here at Simeo, building the future is our legacy. We'll achieve our goals through partnership, creating opportunities. By working hand in hand, we can accomplish all our dreams. For a better quality of life is now within our reach. Let us take a step for our visions of hope, making future plans for the people to grow in a life filled with happiness and dreams. Here at Simeo, building the future is our legacy. Let us take a step for our visions of hope, making future plans for the people to grow in a life filled with happiness and dreams. Here at Simeo, building the future is our legacy. Building the future is our legacy. At Simeo,
Ladies and gentlemen, without further ado, let us now start our program by inviting the Simeo Biotrop Director to deliver his opening remarks and officially open the program. Please welcome Dr. Zulhamsyah Imran.
Thank you, Indah. Bismillahirrahmanirrahim. Honorable, our resource person today, Dr. Ludora Romero Aldemita from the Philippines. Honorable, our Deputy Director for Administration, Dr. Ferdinand. Honorable, our Deputy Director for Program, Dr. Evelyn Bigchas. Distinguished Manager, Supervisor, and all participants of this webinar. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera untuk kita semua. Om Swastiastu, Nama Budaya, salam kebajikan, salam sehat. Welcome everyone, ladies and gentlemen. First of all, let us say thank you to Allah, which has given guidance, health, and blessing to us. Therefore, we can gather in the Sikh Talk of Affiliate Scientists series event to jointly increase our knowledge regarding biotechnology innovation for food security and environmental sustainability in the changing times. In this occasion, I would like to extend my warmest welcome to the distinguished resource person and the participants, and sincerely hope that this online seminar will benefit the participants and develop further to suit their respective countries. Ladies and gentlemen, the recent acceleration of the technological innovation in biology has offered insights that are being increasingly implemented to address agriculture challenges. One of the challenges that affect the agricultural system is climate change. Yeah. We know that everywhere around in Indonesia and also the Philippines, so many disasters, and then climate change is one of the factor can be increasing of our disaster, natural disaster. Climatic change will affect agriculture, of course, and may lead to the emergence of the new pests and disease. Yeah. Current agriculture approaches need to be modified, and innovative adoption strategy needs to be in place and efficiently produce more food in stress condition and with a net reduction in the greenhouse gas emissions. Yeah. We know that we try to develop the smart agriculture, to anticipate how to increase our food to feed our people, not only in Indonesia, also around the world. Yeah. Biotechnological advance provides key approaches to tackling modern and future issues from food security to environmental change. Yeah. Ladies and gentlemen, crops can be modified faster through biotechnologies than conventional crop, thus hastening the implementation of the strategies to meet rapid and severe climate change. Pest and disease resistant biotech crop have continuously developed as new pests and disease emerge with the climate change. Resistant varieties will also reduce pesticide application and hence carbon dioxide emission. Crop tolerance to various biotech stress have been developed in response to climatic change. Ultimately, the contribution of the biotechnology in agriculture is to improve the livelihood of population by helping to address emerging issues and aiming to maintain adequate food security. Yeah, we know that we try every time how to develop the alternative livelihood, using the biotechnology and also others agricultural technology. Ladies and gentlemen, today we have an extraordinary speaker. Special gratitude to the distinguished resource person, Dr. Ledora Romero Aldemita from the Philippines. She is a director of the ISEEA Southeast Asia Center and director of the Global Knowledge Center on Crop Biotechnology. We have the opportunity to listen, to learn from her how biotechnology can be developed more and more successful. Hopefully, we can learn and increase our knowledge primarily related to the biotechnology and climate change through this event. I hope today's activities can run smoothly and all participants can actively discuss with our extraordinary speaker because, of course, we should not miss this opportunity. That from me, enjoy this webinar and with the state Bismillahirrahmanirrahim, and thanks to God, officially this webinar I open together with you. Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. wabarakatuh. Thank you, Dr. Zulham Shah Imran. Please give applause for our director. Okay, ladies and gentlemen, the opening remarks conclude our opening program this morning. Now, may we have your cooperation to have photo taken? Please activate your video. Thank you. Please activate your camera for the photo taken. Okay, let's restart. Okay, click. Okay, done. Thank you very much, everyone. And ladies and gentlemen, before starting the program, we would like to deliver some announcements. First, the participants' Zoom account name is required to use the real name and full name. Second, please fill out the attendance link that will be uploaded in the chat room. Third, make sure the video is on and the audio is mute during the presentation to avoid any noise that can occur. And fourth, kindly use the chat for questions to the resource person. Please don't use it for other topics or internal discussion. And last, for asking question in the chat room, please write the question concisely. Okay, ladies and gentlemen, we are now continuing to the talk or presentation session. This session will be moderated by Mrs. Anida SSE MTPN. Before the session begins, allow me to introduce the moderator. Mrs. Anida was born in Bogor on 22 February. She is the head of Biotechnology Laboratory at Simeo Biotrop. She obtained her bachelor degree from Department of Chemistry at Pakuan University and obtained her master degree from Department of Food Technology at IPB University, Bogor, Indonesia. And without further ado, I would like to welcome our moderator, Mrs. Anida SSE MTPN, to lead the session. All right, Mrs. Anida, the time is yours.
Okay, thank you, Miss Indah. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Honorable Director of Simeo Biotrop, Dr. Zulham Shah Imran, and Deputy Director for Program, Dr. Evelyn, and Deputy Director for Administration, Dr. Ferdinand, and also Honorable Dr. Rodora as our research person today. Distinguished manager, supervisor, and all staff and all participants of this webinar. Before we start the session, allow me to introduce myself again. My name is Anida. I'm from Simeo Biotrop, and I'll be your moderator in this webinar session. I'm glad to see you here and welcome all of you to this webinar. TAS, or Talk of Affiliate Scientists, is one of the webinar series held by Simeo Biotrop in February 2021. As a forum for our affiliate scientists to share their knowledge. And it's also a part of Biotrop 100 or Biotrop in 100 Days program. And now TAS has become our regular program. And today we are going to the 6th series of TAS with the topic Biotechnology Innovation for Food Security and Environmental Sustainability in the Changing Time. And for our information, the total number of registered participants today actually almost reached 200 participants. So maybe we can wait the rest of participants. And they are coming from various institutions such as research agency, government, school and university, private sector, and NGO. Ladies and gentlemen, although this webinar is delivered in English, please don't be hesitant to deliver your question or maybe suggestion or idea either in English or in Bahasa. Both are welcome. Bapak dan Ibu peserta webinar dipersilahkan nanti untuk menyampaikan pertanyaan maupun hal lainnya terkait dengan materi ini dalam bahasa Inggris atau bahasa Indonesia. Before the presentation begin, I have a few housekeeping announcements to cover about this sharing session. First of all, the webinar will be in 2 sessions. The presentation session will be in 1 hour and followed by the discussion session in 30 minutes. Kindly type your question into the chat box if you have any question, or you can also ask the question directly to the speaker at the discussion session. We would appreciate if you could turn on your camera during this webinar. And today's webinar is broadcast live on YouTube. Now, it's my pleasure to introduce our speaker today. She is Dr. Rodora Romero Aldemita from the Philippines. She is the Director of Global Knowledge Center on Crop Biotechnology of the International Service for the Acquisition of Agri-Biotechnology Application, ISA. Now, yeah, you can see her CV in the slide. Yeah, good morning, Dr. Rodora. Morning.
Good morning, everyone.
Yeah. How do you do?
I'm okay. Thank you so much. I've been traveling and I have already recovered my jet lag, so I'm fine. Thank you.
Okay. We are excited about this webinar. Please join me in welcoming Dr. Rodora Romero Aldemita to deliver his presentation. Dr. Rodora, virtual floor is yours.
Thank you so much, Dr. Anita. I'm very happy to be here once again. I've been traveling to Indonesia almost every year because we have the Indonesia Biotech Program Office or Biotechnology Information Center, sorry, which is based in Bogor. And we have Dr. Bambang Ponwantara and of course, Dewi Suryani, who have been with us for the last 2 decades, I think. And so because of COVID, we missed traveling to Indonesia. I used to go there to launch our brief. And now I'm going to present to you what we have been doing for the last few years and how we meet the obligations of scientists to deliver products to our farmers. So thank you so much for inviting me. And thank you, Dr. Zulham Shah Imran, also for the opening remarks and for accepting my suggestion to come over. Congratulations to the talk of affiliate scientists. And I know that this has been going on and I'm the sixth. And this is something new. I think I'm going to suggest this to Simio Circa Simio in the Philippines. This is one good idea so that we can have other scientists to come to the Philippines and give sort of talks, several talks on different topics. So if I may share my screen, I'm going to start with my talk. Actually, I am from, oh, sorry. Okay, slideshow, okay. Okay, that doesn't work. Let me do this again. Okay, all right. So you can see my slide in slideshow, okay? Yeah, yes. So yes, I'm from the Philippines. This actually, ISA is an international organization, and we have 2 centers, 3 centers at the moment. We have Southeast Asia Center, Afri Center, and the Ameri Center based in Cornell University. So in the Philippines, we are based at the International Rice Research Institute, and we've been there for more than, I think, about 29 years. So during that time, ISA has been publishing the Global Status Report, the Yellow Book, for example, which has catered to many publications and narratives on different topics. That includes crop protection, partnerships, intellectual property rights, and of course, a very well cited, the very much cited Global Status Report of Commercialized Biotech Crops. So in my talk, which is on biotechnology innovations for food security and environmental sustainability in the changing times, I'm going to discuss with you both technologies, genetic engineering and genome editing. So first, let me start with my talk. So this is what Dr. Sulham Shah has been telling us, that we need a new technology to address problems of high global population, which currently has gone up. We have now 7.9 billion people in 2019, 2020, and it is estimated that it is going to go up much more in 2050, and we will need to increase our food production by 70%. On top of that, this is the heavier problem that we face is climate change. Since the advent of climate change, we will be affected very much our food production because new pests and diseases and abiotic stresses will come. So this will include drought tolerance, submergence, high extreme temperatures, low temperatures, and others. So it is very likely that 20% of all our countries, low-income countries, developing countries such as ours, will be very much affected. So it's 20% likelihood. And we know that the United Nations Global Development Goals have not been met in 2015. So we're looking forward to the Sustainable Development Goal 2 of zero hunger by 2030. And this cannot be achieved by the usual conventional breeding that we're used to. So we're looking here at why we are needing by the crops. So that is my talk, which would be what biotechnology can do in these changing times. So to start, we already know this. We are in an institute, a research institute in Bogor, and we know that DNA contains the genetic code of life. So this is the basis of all the sciences that we have
Pardon,
studied.
Dr. Rodera,
Yes,
maybe you can change your slide.
yes, I'm changing my slide.
The slide is still on the cover slide presentation.
Oh, I am moving it now.
Okay.
Okay, let me unshare it and share it again, okay? Right, I'm sorry. I am already in the fourth slide. Okay, let me do that again. Can you see it?
Yes, this is clear now.
Okay, so wonderful. I'm sorry. So before I was talking about this, why buy the crops, why we need it. And so now, so we're discussing that DNA contains the genetic code of life and that every organism has these sequences, the pairings, but each of them are of course unique. And because of the coding sequences that we hold, we can have a cutting and pasting and putting together genes that are coming from different organisms so that we can have the desired phenotype. So am I changing my slide?
Yes.
Okay, wonderful. So when commercially when cultivation came into being, our former developers, our food producers, our old farmers used to do the traditional breeding. Yeah, this is when we cross plants and selected offsprings, and because we know what we want. But because of the changing times, the increasing population, and the many stresses around us, traditional breeding is not enough. So our scientists moved on and made some new strategies, including mutagenesis, where we expose seeds to chemicals or radiation so that we can have new varieties, new seeds. And then by the advent of the 1980s, our scientists discovered the development of transgenics. That means we can have an insertion of selected genes using recombinant DNA methods. So from this time on, we were able to produce many different genetically modified crops, which have improved our lives. And then later on, by the advent of the late 1990s to early 2000s, our scientists started working on gene editing. So actually, this is the scope of my talk, which would be transgenic and gene editing. We can start with the transgenics at first, where we insert selected genes using recombinant DNA methodology. So here, Using that genetic engineering, we were able to fight disease, increase yield, environment-friendly products, safer crops, nutritious food, just like vitamin A rice, and for better industry. We have seen how this development has impacted our lives for the last 25 years, especially with the development of crops which have increased yield, safer crops, and nutritious food that provided food for every people in the world. So today I'm going to discuss with you what has happened during the last 24 years or 25 years when global biotech crops have been adopted by different countries around the world. So this figure shows that in 2019, we had around 190.4 million hectares planted to genetically modified crops. And you have seen here that the developing countries in red has increased tremendously from in 1996 to 2019, where it has surpassed the area planted compared to the industrial countries. This shows that our farmers are now accepting the technology that brings fruits or that brings improvement in their lives as we go forward and as we help the feed a global population. So 55.5% of the global area were planted in developing countries and 44.5% by industrial countries. So to detail which countries these are, I'm showing you the 29 countries that have planted by the crops for the last 25 years. So we have, of course, the top 10, you will see there, headed by the US. And then Indonesia is somewhere at the bottom with less than 50,000 hectares. And the Philippines is number 12. Now, looking at the continent-wise, we can see that in the Americas, 88.2% are planted in the Americas, so in the North America and in the South America, and 10.23 in our area, in our region, the Asia Pacific, and 1.5% in Africa, and 0.06% in Europe. Now, I'd like to emphasize that in 2019, there were 3 new additional countries that planted biotech crops. This includes Nigeria, Ethiopia, and Malawi. These are all for BT cotton. So there were 10 Latin American countries which planted, 9 Asia Pacific, 2 North American countries, 2 in the European Union, and 6 in the African countries. So looking at the adoption rate, in 2019, these were the 5 top countries which planted biotech crops. The US leads, followed by Brazil, Argentina, Canada, and India. And I'd like to emphasize with you the adoption rate, 95%, 94%, close to 100, and 90 and 94%. This shows that in these countries, adoption of biotech crops have been going on, and adoption is very close to saturation, meaning more as we move forward, in our food production, these countries need to excel in new crops and new traits so that the adoption rate will increase. Now, you see here that there were 3 developing countries, that includes Brazil, Argentina, and India, and 2 industrial countries. So the crops that were planted in 2019 are presented here. And of course, in the US and Canada, these are maize, soybeans, cotton, canola, sugar beets, alfalfa, papaya, squash, potato, and apples. And in our area, Asia and the Pacific, we have cotton, which are planted by India, Pakistan, China, Australia, and Myanmar. Maize is planted by the Philippines and Vietnam, canola in Australia, eggplant in Brazil, and of course, drought-tolerant sugarcane in your country, Indonesia, and safflower also in Australia. And you may notice that the top 4 biotech crops are maize, soybeans, cotton, and canola. So I have also highlighted here the three new countries in Africa. So in terms of crops, biotech soybean has been the most planted biotech crop all over the world. It has been planted in 91.9 million hectares. And this is followed by maize, cotton, and canola. And in 2019, it is very important to note that for the first time, Brazil surpassed the US biotech soybean area. And of course, this is a trade issue between the two countries, but we know now that Brazil is doing its best in helping or in contributing biotech crops to feed the global population. In terms of global adoption rate, so I'm telling you here, the global area planted to the crop, so this is cotton, so 79% of the whole cotton planted all over the world is already GM. So whatever we wear, we use for clothing and for other purposes, it's already GM if it is from cotton. And 74% already of the total soybeans is biotech, 31% for maize, and 27% for canola. It is important to note here that soybeans and maize are very important components of the feedstock for livestock and poultry. So we would like to see more of our global maize to BGM because of the very good production rate that they get from GM maize. In our area, in our region, these are now the countries which have planted by the crops. Indonesia was the recent addition, which planted, I think, in 2018. And then, of course, so 9 planting and 8 importing countries. And then these are the importing countries. Although they do not plant, they import a lot of food, which are GM from GM developing countries. So, for example, Japan, Malaysia, and Singapore are big importers of biotech crops from GM producing countries. So in terms of trait anyway, you can see here the development of the stock traits. In the beginning, we can see that insect tolerance and herbicide tolerance were starting very high. And then herbicide tolerance went up because of the problems on weeds. Weeds are the most destructive pest in agriculture. And we see that weeds, herbicide tolerance, this can be in cotton, in soybeans, in corn, and in canola, and many other GM crops. But you may see that by 2019, here, the stock traits, meaning varieties which contain both traits, insect resistance and herbicide tolerance, has increased very much. So it means also that farmers would like to save on seeds, and they're looking at seeds which could target both insects and weeds. So with that, I'd like to move on to the new biotech foods and feed. And I'm now presenting to you the non-browning potato, which is now planted in the US and Canada. So this is when you slice the potato, it will not turn brown. So it decreases the wastage that happens in many countries of the world, including USA and Canada. Of course, it is not nice to look at brown potato. The same technology has been applied to non-browning apples so that when you open the apples, it doesn't turn brown as much. And this has been commercialized as well in the USA and I think in Canada. We also happy to note that Bangladesh has already planted BT eggplants since 2015, and the Philippines has given approval for food and feed and processing for BT eggplant just this year in June 2021. And we have the low lignin alfalfa, which is being used for foraging our livestock. And this has been in cultivation in these countries, USA, Canada, and Argentina, in the last 4 years. Another set of expanding adoption, of course, is insect-resistant sugarcane in Brazil, where they have planted 18,000 hectares. And then, of course, in your country, 2,000 hectares of drought-tolerant sugarcane. We have high oleic acid safflower in Australia. And of course, the very famous pink pineapple, which has been planted in Costa Rica and is now very much in demand. You can order pink pineapple seeds through online marketing and you can have it. And also, we have approvals in 2019, the same crops, but we have new traits: drought tolerance, low gossipol, non-browning, high polyunsaturated fatty acids, multi-insect resistance, and also drought tolerance and herbicide tolerance in these countries. We know of other materials or other crops which are now being developed for approvals in 2020, which we will be reporting to you next year. So some by the crops in the pipeline, we have the non-browning romaine lettuce, Colorado beetle-resistant potato, drought-tolerant wheat, which has been approved anyway when I was presenting this last year in Argentina, and then in Argentina and Brazil. And then nutrient use efficient, water use efficient, and salt tolerant rice in cooperation with the US universities and African research agencies. So this is one of the examples why we need to use by the crops. So you see here that this is the historical trend of how yield has been improved in corn. But because of biotechnology, this increase has been tremendous. And this is the biotechnology yield, which is now being forecast to be the trend as we go on to advance to more biotechnology, which I'm going to introduce to you in the next few slides. But first, due to those genetically modified crops that I have mentioned, they have, for the last 25 years, contributed to food security, sustainability, and climate change. So we can see here the increased productivity of $225 billion. So there is a gain for our farmers and our consumers. We have provided a better environment because we do not use anymore the hazardous chemicals and we do not use fossil fuels to disperse or to spray our fields. We conserve biodiversity because we don't need to use 231 million hectares to produce this much amount of food. Because in order to increase food, you have to denude the forest and destroying our biodiversity. But with genetic engineering or genetically modified crops or biotech crops, we don't need to do that. So we have conserved 231 million hectares. We have reduced carbon dioxide emission equivalent to 15.3 million cars from the road for a year because we're not using any more fossil fuels to spray our fields. And most of all, we help alleviate poverty and hunger of 17 million farmers all over the world and their families. So now let's move into the next part of our talk, which will be the evolving plant science. We have discussed about the plant breeding, about the beginning of genetic modification. Now we're moving into gene editing or genome editing. And this involves the activation of unfavorable characteristics, or we can enable a beneficial character just by cutting and putting back the strands of DNA together. So currently, gene editing is a technique, as defined, that allows plant breeders to make targeted improvements within a plant's existing DNA. So gene editing tools such as CRISPR-Cas9, we have talons, we have zinc fingers, will help plant breeders integrate desirable traits into improved seed products with greater efficiency and precision than ever before. So this is a slide from the International Seed Federation, and they are now helping all our scientists doing genome editing to reach out to our stakeholders to accept biotech crops which were derived from genome editing. So this is how it is done. So we can have deletion or loss of function by just knocking out one base, and then, or we can replace that gene, that base with some other bases so that we can have an improved function. So currently, these are the potential benefits in agriculture of genome editing. So farmers and consumers and the whole of the planet can be benefited by improving the pace and scope, meaning this technology is faster and it can cover a lot of problems in our farmers' fields, and it will help our farmers produce more food. It can help consumers because it will meet society's needs, food variety and supply, while minimizing the environmental impact, which is the problem that we're facing now. And the planet, that is farming solutions that allow for smarter use of inputs like pesticides and natural resources like water, energy, and land. So currently, these are now the potential applications. Again, it is towards farmers' problems of weed management, disease resistance, drought tolerance, to our consumers, quality improvement, and enhanced nutrition. So currently, this is what is in the pipeline or in the market. So we have this is already approved for commercialization. It's already in the market since last year. So this is Calino, which is the high oleic acid oil from soybean, and it is now commercialized. And of course, the very famous GABA tomato, which has been developed in Japan, which enhances blood pressure lowering. This is also available in Japan, and you can even order seeds for high GABA tomato. These are very, very exciting times, and we know that a lot of our products are being improved. So we want to continue that to ensure economic benefits of biotech crops, both genetic modification and both genome edited derived crops. So we need to go for forward-looking regulatory steps that should be based on science. We need to look at the benefits instead of risks. And we have to look at the productivity with environmental conservation and sustainability. We need to help our consumers, our farmers, and to feed millions of hungry and impoverished population. So biotechnology, both genetic engineering and genome editing, continues to be important to meet the 50% increase in food demand by 2050. So with that, thank you very much for your attention. And I would like to invite you to come to the ISA website. I forgot to include that we have already launched the first edition, or how do you call this, the first publication of ISA on genome editing or new breeding innovations. Last Monday, we have launched this, and if you can look at our website, go to our website and you can download that primer. It's called Breaking Barriers Through Breeding, a primer on new breeding innovations. You can download it for free from our ISA website and enjoy reading it. It's really for newcomers, for beginners, of people learning how to understand new breeding innovations, including CRISPR, talents, and all of that. Thank you very much for your attention, and thank you so much for having me here.
Yeah, thank you so much, Dr. Rodora. It's very interesting presentation. We now could get a clear explanation of why do we need biotech crops, especially in the changing time, and biotech application like transgenic or gene or genome editing are promising as a solution for food security issue globally. It could be improve crops through fighting disease, increasing yield, developing nutritious food, and also environmentally friendly and safer crops. Okay, ladies and gentlemen, now we have a discussion session. Please don't be hesitant to could directly deliver the question. Please raise your hand so I could see it, or maybe we can check the chat box. Is there any question from the audience? Zul, maybe you want to give some.
If there is still no question from the participant, I just want to make sure that we know that the biotechnologies seed and others product can be useful, can be useful for our environmentally friendly agricultures. Yeah, of course, not only for Indonesian country, but also from the Southeast Asian countries and also around the world. Yeah, but yeah, we know that our challenges now how to develop in the developing country such as Philippines and Indonesia. Yeah, we know that Indonesia not just one seed produced using the biotechnology that we call sugar cane. Sugar cane, sorry, yeah, sugar cane, sorry, sugar canes, yeah. But we know that we need in Indonesia, more seed come from the biotechnology product, yeah. For example, we need the potato and then banana and so on and so on, so many. So what is your suggestion for the strategic development, the biotechnology seed, can be accepted for the people? I mean, for the farmer. I mean, for the consumers. Because we know that is one challenges. They worried about when they eat the product, agriculture product. Using the seed. Production from biotechnology. That all. I think my question, Anida.
Okay, sir. Thank you so much, Fazul. Dr. Rodel, please, your comment and suggestion.
So there are many aspects in that question. So first one is for the researchers. Of course, our researchers have to be given support so that they will continue their development of biotech crops so that they can be able to have access to the technology. They can partner with developed countries to start putting together their own laboratories. I know that I've been to Biotrop and I've been in Bogor. So I saw how very update you are in your laboratories. So it's just that you have to partner with advanced institutions so that you can have the technology be in place in your institute. And the second question would be, how would our consumers, farmers, how would the stakeholders in Indonesia accept biotech crops? And of course, I would like to mention here that we have the INDOBIC, or the Indonesia Biotech Information Center, which is an arm of ISA, to help raise awareness on biotech crops. And INDOBIC is doing a lot of efforts so that the awareness on biotech crops will rise or will be raised in your country. And we know that one of the things that can be of help would be the political will in your country. One example that we have is Bangladesh. Bangladesh is a poor country, but because of the support of the government, you can imagine that even the Department of Agriculture minister was the one who launched BT eggplant, and she's the one who distributed the seeds to the farmers. This is a very good example of how the government supports farmers. And this political will is still ongoing. And I think with political will in your country, this would also help alleviate fears on its safety. Because if it's the government who says it's safe, then our farmers and our consumers will be able to understand that it's really safe. Now, you can also say that in the last 25 or more than 25 years, but there has not been any lethal or any deaths associated with biotech crops. And so this is a sure example, um, a sure history that there is no hazardous effects of biotech crops. And also, I think Indonesia has a very good regulatory system in both food and feed safety, and of course in environmental safety. I've been in association with many of the Indonesian regulators. They ask me about what's going on in the Philippines, what do they have, can we still adopt it? And I know that Indonesia has good policy considerations not only in GM, but also in genome editing. They are still discussing about that. And these are the things that you can tell your people or the Indonesian public so that the acceptance of biotech crops is raised. Also, we can see that scientists such as you in Biotrop are good speakers, are good supporters of biotech crops. In the Philippines, we use our scientists because they talk the immense benefits, the immense nutritional contribution of biotech crops, especially now that we have the vitamin A enriched rice, which has been approved for cultivation in the Philippines. Thank you.
Okay, thank you, Dr. Rodora, Dr. Zul. Yeah, it is very interesting. At least we have 2 points from Dr. Rodora. First of all is we need to raise the awareness of dissemination of information about the biotech crops, and also the political will from the regulator or the government. Because as we see in your slide for the Asia Pacific countries, especially in Southeast Asia, there is a low number of land that adopt biotech crops. Is that right?
Mhm. Yes.
Okay.
Yes.
Now
Right.
we have one question from Dr. Eve. She is our Deputy Director for Program. Dr. Eve, are you there? You could deliver your question directly, maybe.
Yes, I am here. Thank you, moderator. Yes, good morning, Dr. Rodora. I'm Evelyn. I'm a Filipino also. I just would like to ask, when you said that just to quote you, we look at the benefits rather than the risks. Now, what kind of risks are these that can be sort of ignored or be yes, that's it. Yeah, doctor. So the risk that can just be ignored or yeah, that's right. If I understood it right, your
Yes, thank you
statement.
so much. Yeah, when
You.
GM Crops, hi Eve. I think I know you by face. Uh, when we mention the risks, these are the items or these are the issues that were raised by those who do not believe in the technology, because they were saying that there are risks for food safety, there are risks for the environment, there are risks for underground water, etc., etc. Now, when you look at those issues and you study the issues very carefully, you will see that these are not risks at all. So when these issues are raised, you shouldn't highlight those. You should highlight the benefits. So when you go to the field, when you go talk to many stakeholders, you have to highlight the benefits so that they will not think of the risks anymore. Because currently, all of the risks that were raised long time ago have now been responded to. And we do not focus on those risks anymore. So, for example, one of the risks that food safety risks that they were saying is that the genes that we eat will integrate in our body, and we would be producing green color in our body because we're taking the genes. So it's not a scientific basis. There's no scientific basis on that. So what you will say is that the benefits of taking improved crops with nutritional components such as vitamin A that will improve vitamin A, that will delete or eradicate vitamin A deficiency and sort of like that. So those are one of those, that is one of the examples. And then when you say, for example, environmental safety, will it produce, this is an issue raised by the other, the anti-technology people, that in, if we have weeds, will it produce monster weeds? Will it have any effect on the development of herbicide resistance? So these have been responded already. So you just have to focus on the benefits of using herbicide tolerance. So that is what I mean by looking at, talking about the benefits, not the risks anymore, so that people in, or the stakeholders will not be confused anymore. Thank you so much for the question.
Thank you, ma'am. Thank you for that answer, Ma'am Rodora.
Yeah.
Thank you, Bu
Yeah.
Anida.
Thank you, Dr. Eve and Dr. Rodora. Yes, agree. A lot of safety issue in biotech crops that we should, but we should address that all the risk is should be based on the scientific evidence. Yes, we agree with that, and we should take more to the benefit instead of the risk. Cause risk could be handled, could be managed. Is that right?
Very good. Yes, that's how it is.
Okay. I will invite the participant to deliver the question directly. Is there any question for from the participant?
Yes, I'm moderator.
Okay, Miss Sela Marlinda from
Okay,
Biotech.
thank you. Thank you, moderator, and good morning, Dr. Rodora. I'm Sala, I'm from Biotrop, and I want to ask you about how does gene editing acceptance compared to transgenic?
Okay.
Thank you.
Yes, thank you so much for the question. Actually, this there has not been any study yet on the acceptance of genome editing compared to GM. But if you will look at the, if you can download, you go to the ISA website, go to and download the primer on new breeding the innovations. This has been discussed very well by Dr. Maha, who talked about communication, and also by another one was Dr. Gabi Romero, who talked about how certain countries who have planted GM crops are now understanding the biology and understanding the science, such that they are also accepting genome editing. So there are regulations being developed. For example, in the Philippines, which is already at the last stage of signing, the protocols for genome editing, how policy considerations are being done for genome editing. We also have a study on Japan, and also somehow I think there was a discussion in China. And you may see that some of the countries, for example, Japan has not been planting biotech crops, but they are a big importer of biotech crops, especially soybean. But you see, they are one of the first country who have commercialized tomato, the genome edited tomato. This is one big step for Japan, that Japan is accepting genome editing much more than genetic engineering. And also Japan has already in the pipeline, I think they have already approved the commercialization of genome editing sea bream. And in the pipeline, it's a fish, and the genome edited puffer fish which is still under discussion. So Japan is one of those countries which have, well, they accept GM, but they do not cultivate. But now they are accepting genome editing for food and for commercialization. Thank you.
Thank you, Dr. Rodora and Ms. Sela. Yes, it's we know that they already genome editing product in the market. The example is the tomato. So I'd like to giving another question related to the gene editing. Is there any different acceptance of genome editing product in the industrial country compared to the developing country?
Mhm. Okay, this is another one that you can look at the primer. It's being this. It's very nice. I'm really trying to call your attention to the primer because it's an easy to read material because we wanted people to understand what's going on. There's a section there on regulations, and this is written by Dr. Martin Lema from Argentina, and he explained here how different countries are working on their policies. We're not looking anymore at regulation. I mean, the word regulation is not anymore being used, but well, the title of that section is Regulating New Breeding Innovation Products. But we are looking at policy considerations because of course, in genome editing, you already know whether SDN1, SDN2, and SDN3. Some of the countries consider SDN1 and SDN2 as none that shouldn't undergo regulation. So they are already policies. So just like Argentina, Australia, I think the Philippines also are considering that SDN1 and SDN2 shouldn't undergo the regulatory system anymore. So it could just be a registration or just registering the varieties, just like the usual method that we use if we develop a variety through conventional breeding and we want it to be approved for cultivation in the country, we just register it. And so these countries are enabling our scientists to develop products from from genome editing that can easily be deployed to farmers. So the regulatory considerations or the policy considerations are much more acceptable. Yeah, thank you. So please go and check the primer. Thank you.
Okay, thank you, Dr. Rodora. Again, I will ask to the floor. Is there any participant who have a question? Please don't be hesitant to deliver your question or suggestion or maybe idea directly to the speaker. Please, you can unmute your microphone and deliver your question directly. Is there any participant who has a question? Please raise your hand.
While we're waiting for questions, I would like also to emphasize that in genome editing, the risk assessment, some of the countries will not require risk assessment anymore because they know that the products that are improved in genome edited products are already in existence in the country. So for example, in the Philippines, we have this bacterial blight resistant rice. So the bacterial blight resistance has been incorporated, the gene has been incorporated into rice long time ago, and it took them years before they developed the bacterial blight resistant rice. It's already there, but it took them 20 years. Now, due to biotechnology or due to genome editing, a new set of bacterial blight resistant rice is there. So with this, since it's already present through conventional breeding, and we just made it more resistant using another method, so it's not going to undergo regulation anymore because it's already present, the trait is already present in the genome pool of rice. And if you're looking at food safety, of course, since the gene or the trait has been there for a long time, so there is no issue anymore of risk for food or uh, food related or biotech related food problems because food safety has been improved or food safety has been there using the conventional breeding. It's already there. So it's not anymore going to be an issue on genome edited crops.
Yes. Okay, thank you, Dr. Rodela. Now we have Dr. Oki. She's our one of the affiliate scientists. He would like to deliver the question directly. Please, Dr. Oki.
Thank you, Mrs. Anida. Good morning, Dr. Rodora. I'm affiliated scientist from Biotrop. Yeah. Your presentation is very interesting, especially related for me is based on biotechnology crop. One of the example, for instance, related with disease resistance. For instance, resistance of rice caused by blast disease. Blast disease is caused by Pericularia oryzae, pathogenic fungus. If we have already rice resistance to this disease, but the pathogenic fungus Pericularia oryzae, it can be happen that this pathogenic fungus can be mutation naturally. Naturally. How about your opinion about this? And the second not question, I think, if the production of crops is already abundant, for instance, we have to be attention also to the production after harvest, because we should be carefully store the food crop, the food stuff carefully, so not only when the crop is still in the field, but we should pay attention also after harvest. I think that's all, Dr. Antula. Thank you.
Thank you so much. Thank you so much for those two questions. Those are both interesting ones. Yes, I'm a rice scientist by training, and I was at the International Rice Research Institute. I was a plant pathologist, actually, a virologist before I went into biotechnology, and I'm familiar with Pyricolaria oryzae, and I know how fast it mutates. So this is the more important that we use genome editing because we know that these pathogens mutate as fast as they develop. And we have to make sure that the sequences that we target in to genome edit rice would help us be resistant to Pyricolaria oryzae. So one of the technologies that the scientists at ERI is doing is to identify which part of the gene is going to be the sequence that codes for the acceptor or the receptor or one that will induce the infection of pyricolaria. So if this is identified, so this gene can be silenced, can be cut, the sequence of DNA can be cut so that it will not anymore produce the receptor or the binding anchor for the pathogen. So through genome editing, this can be done. I have no idea if this has been done already, but this is the technology that has been used in
Ayo
developing.
ibu-ibu, bapak-bapak, kan kita ada Zoom. Zoom kan dia di handphone.
Hello,
Kan?
please, to the other participant. Don't forget to unmute your microphone. Thank
Thank
you.
you, Dr. Adora.
So this is the technology that has been used to develop the bacterial blight-resistant rice. And I know that this can also be used for pericularia. Now, in your question on post-harvest, this has been an ongoing research already. We know that rice, legumes are very much affected by post-harvest pests, especially in areas, of course, in our area, which is a tropical country. We're tropical countries. We are the good haven for post-harvest insects. And this is one of the things that is being targeted right now. And there are many possibilities using genome editing, and post-harvest is taking care of our seeds after harvest is one of those. Thank you.
Thank you, Dr. Adora.
Thank you, Dr. Oki, for the question and for Dr. Rodora. Okay, if there is no more question from the participant, I will end this. I will end this discussion session. So allow me to conclude our discussion session in this time. From the presentation, Dr. Rodora, and the discussion session, we know that biotech crops are important in facing food security issue and creating environmental sustainability. And biotech application could be the solution, such as transgenic and gene or genome editing. There are a lot of crops that have been planted in both industrial country and developing countries since 1996. The four major, we know that cotton, soybean, maize, canola, and they have expanding adoption of biotech crops such as non-browning potato, non-browning apple, and etc. Genome and gene editing as a new tool in genetic engineering to edit the targeted gene or purposes. It is very precise and more efficient in time, and has many potential benefits in agriculture. And there is already a gene edited product in the market. And in the closing presentation, Dr. Rodora is giving highlight the potential of the benefit of gene editing for the whole global population. Let's take a look the benefit first instead of the risk, because the risk could be managed. Okay. I want to thank to the speaker for the informative and exciting presentation, and for the participant. Also, finally, let's give applause to the speaker and for you all. Yes, I'm Anida. That's all for me. I give the floor back to the MC, Miss Indah. Thank you.
Okay, thank you very much. Ladies and gentlemen, that's the end of the presentation session today. Thank you to Dr. Rodora Romero Aldemita for your very informative presentation, and thank you to Mrs. Anida as moderator to make this program more interactive and interesting. Please give applause for Dr. Rodora and Mrs. Anida. Okay, and I would like to remind you again, please fill out the attendance link that have been uploaded in the chat room. Before we finish this program, may we have the honor of inviting Dr. Zulham Shah Imran as a Simeo Biotrop Director to deliver his closing statement and officially close the program.
Yeah, thank you, Ms. Indah. I'm really appreciate what the Dr. Rodora deliver his presentation about the biotechnology can be used not only for the agriculture but also others product in terms of the what can be consumed to the people. Yeah, we know that the fisheries and then forestry and also others. Yeah, including, we know that nowadays we use the biotechnology approach, how to save and give the security for the human also. We know that so many biotechnology product already used, for how to save our peoples. Today we got a lot of information how about how the biotechnology develop around the world. Not only in developed country, but also but developing country. We know that we still have some obstacle can be solved not only by the government of Indonesia, the government around the Southeast Asia country, but also we need to make sure the people who crops, who plant and crop this biotechnology product can be well accepted, and then the big challenge is how to make sure and campaign to the consumer that they can consume safely for the biotechnology product. So finally, I hope we not only just discussion in this talk of affiliate scientists even today, but also we can continue with how to arrange the real action to develop our biotechnology product. We know that Simeo Biotrop has the small laboratory for the biotechnology, and also we have the unit to communicate. I mean, how to delivery of the information about the technology. Dr. Rodra Noel, Dewi Suryani, and Professor Bambang Purwantara. But in the future, we should develop more sophistication for our biotechnology. And the big challenge, how to ensure our elementary school and I mean it's junior school and high school, they want to get and continue their study in terms of the biotechnology field, Bu Anida. That all from my closing remark today. Again, I would like to say thank you for Dr. Radura, the resource person today. Very nice presentation. And then Dr. Anida, as Dr. Radura mentioned, and then of course Miss Indah, and all organizing committee, and also of course here Professor Oki and others participants who attend this very fruitful event today. I hope we can meet in another event. Officially, I close this meeting. Of course, I hope we can meet again. Thank you so much.
Thank you, Dr. Zulhamsyah Imran. Please give applause for our director. Okay, ladies and gentlemen, as the final program, may we show the symbolic appreciation from Dr. Zulhamsyah Imran as our Simeo Biotrop Director to awarding the certificate of appreciation virtually to Dr. Rodora Aldemita in recognition of her precious contribution as a resource person during the webinar.
Oh, okay.
Okay, congratulations, Dr. Radora. Thank you very much for your excellent presentation. And please give applause again for Dr. Radora.
Thank you so much.
Okay, ladies and gentlemen, that's a talk of Affiliate Scientist Series 6 with the title Biotechnology Innovations for Food Security and Environmental Sustainability in the Changing Times. And for the information, the material link and a certificate will be sent to each participant who has been filled out the attendance link. This material link and e-certificate will be sent via email within 1 week after the webinar has been finished. On behalf of the organizing committee, we apologize for any shortcomings. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh, and good afternoon, everybody.
Thank you.